Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast, where every day I explore emerging technologies that are transforming our world and try to demystify them and talk about them in a language that everyone can understand. And maybe, just maybe, that way we can make these topics more approachable for everyone and also help increase adoption in the process. So after I discovered a company called PraSaga and how it's building a next generation of layer 1 blockchain, I felt compelled to find out more. So today, Rich Phillips from PraSaga will be joining me in conversation about how this technology solution is solving many of the limitations that plague first-generation Layer 1 blockchains. What are those issues? How are they solving it? What is the architecture like? These are just a few of the topics we'll explore today. So buckle up and hold on tight as I beam your ears all the way to France, where Rich Phillips is waiting to talk with us today. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
Yeah, so Rich Phillips, I'm the Chief Product Officer at PraSaga, and we're a new Layer 1 single-layer blockchain coming to the market.
What I'd love to do here, Rich, is take you back in time for a moment. Can you remember where your passion and curiosity for all things blockchain come from, or just something that put you on the path that you're on today?
Happenstance and pure opportunity.
Yeah.
As is often the way with these things, right? So yeah. I have spent probably over 20 years of my life deep into kind of industrial sort of engineering companies, GE and Lockheed Martin and those kind of things. And at one of the various conferences that I was attending and presenting at, I met up with the CEO of PraSaga, Michael Holden. He wasn't running PraSaga at the time, and wasn't even really an inkling in his eye at the time. He was talking around his IoT play that he had at that point. We stayed in touch, and when I exited the corporate world, he saw my sort of LinkedIn profile change as to, hey, I've got an opportunity. Let's have a chat about what that might be and what it looks and feels like. And with that, I started to learn a little bit more about blockchain and what that really sort of means. My only sort of real dealings with it till that point in time were very much kind of, the public persona, the Bitcoin, the Ethereum, the crypto rises and falls and all of that stuff. So definitely intrigued, knew roughly what the technology could do, but not in enough detail. So it's been a fairly steep learning curve, but my sort of role to play with PraSaga is very much a feet in two camps kind of a position, where I am understanding not only the technology that we're building, but also how the end user may actually want to use it, kind of in the industrial spaces that we're looking to put this into.
I love that path there and how that led you to PraSaga, which is on a mission to build the next generation single layer blockchain. But Alan, I'm aware that we'll have some people listening that'll be from your community wanting to find out more information. And equally, there'll be a lot of people listening completely oblivious to who you are, what you do, and maybe feel a little bit intimidated by that space. So can you just set the scene a little and tell the people listening outside the industry and a little bit more about the story behind the company?
Absolutely. So, okay, let's take the back history. So PraSaga started as an idea in 2017. We were looking at how we could be a sort of data hub, if you will, for a smart city IoT type of play. Given Michael's background, a lot of the data communications protocols that he was creating were very much designed around Internet of Things, connectivity, and passing data back and forth. And he was looking at how could you monetize the data as an individual. How could I, with all of my machines generating data, how could I make money from that? Because data is the new oil. We've been saying that for the last 6 years plus. And so it would be a good opportunity for somebody to figure out how we could leverage the data that we're all generating to actually bring in a new bottom line for folks. There wasn't really any technology on the marketplace that solved that particular need. So we thought, okay, we're going to need to create something, and blockchain had been around a couple of years by then. Blockchain as a financial transaction processing system makes a lot of sense. It's a little bit like running a bank account. You can transfer things, data or coins or whatever it may be, between different accounts. And it creates this immutable list of all of the transactions that have occurred through time in such a manner that can be audited, and you can be assured that everything is entirely correct and validated and everything else. And that's really the power of the blockchain generically. You can create this infinitely long list of all of the transactions, and nobody can challenge that to say that it wasn't true or it's been tampered with. You've had all of these different servers on the chain have validated that those transactions were in fact correct. And so when we were looking around at different blockchains that existed at the time in the market for the sort of characteristics that we required in order to handle the sort of data volumes and the type of transaction processing we needed, there were a couple that came close, but frankly, none of them really ticked all of the boxes that we were looking for. And that kind of led us down that tricky decision path of we're going to have to probably build something ourselves. We contemplated taking one of the existing and modifying, but that was really second best option. The best option really is let's just go create it new. So that took us into kind of the 2018, 2019 sort of path where we've done the evaluations, we've done that decision point, and we could start to figure out exactly what it is the technology needed to look like. Fast forward a few patents later, and now we have an architecture that's going to support what we need to do. We have dev teams building out the chain, and it's starting to come to life. And by the end of this year, we'll be up and running on effectively a public beta version. It's what's called testnet.
And one of the reasons I invited you on the podcast today is after reading about PraSaga's technologies, trying to solve many of the limitations that typically plague first-generation Layer 1 blockchains. And again, for people just outside of this space, can you expand on what some of those problems are?
Absolutely. So if you look at kind of the two big names in kind of the blockchain and crypto space, Bitcoin and Ethereum, and they both solve similar problems, but they have different fundamental technologies beneath them. So with Bitcoin, you get a lot of security, okay, because they use a proof of work. So I've created some stuff and I can prove that I've done that work, the processing on that chain, in order to arrive to the end of that transaction and validate the block. Fantastic. Very secure. The algorithms used in there are, you can't disprove that work has been done. So it's accurate. Ethereum went down a slightly different path. They were looking more at the scalability side. And so they have a thing called proof of stake as their algorithm, which signs off these blocks once they have been done. And proof of stake is fantastic in terms of scaling your chain to lots of transactions per second, and to be able to handling large volumes of information back and forth. But it's less secure. So you end up with a decision point down either of those two, and a lot of the other chains that have come into existence since those two tend to follow one or other of those two paths, scale or security. So the first big patent that we put into place, and is now, we're a patent holder for that, is our hybridized proof of work, proof of stake algorithm, which allows us basically to get the best of both worlds. We get to have our cake and eat it. So we can scale literally to the bandwidth available on the internet, Plus, we have the security afforded to us by processing and validating like a proof of work. So we literally don't have any downside on that kind of an operation. The other thing that's very apparent within the existing kind of first generation chains is the way they consider processing the transactions. So most layer one chains today have this thing called a smart contract. And what that is some software, some code, typically written in a language like Solidity or Rust. Not very common programming languages right now. And it basically, you are describing the nature of the transaction, what needs to happen from what chain to another chain. You create these software objects one time for each transaction you need to create it for, and then it processes. The problem with the way the smart contracts are handled by the chains is you have to start at the start and finish at the finish. And you have to sit there and wait for that contract to finish processing before you know that it is validated. Some clever people have been able to take those contracts and split them up into smaller pieces. The trouble still exists. You still need to process each one of those pieces in serial because the result of one piece needs to be passed on to the start and input of the next piece. So you end up with a problem which was described in the 70s by a very smart guy working for IBM called Amdahl. There's a computer law called Amdahl's law, which basically says if you are going to process things in series, that is the limit at your computational limit. The speed at which you can process things is limited by how many of these things you can process. And if it's all in series, then the overall speed of your system is limited by the things that you're processing in series. We don't have to do that because we're no longer using smart contracts. We've done away with the notion of a smart contract. Instead, we've actually transitioned back to something that is far more familiar in a banking setup and using an accounts and assets type of system. So everything is an object for us. And so we call these smart assets. Unlike Gen 1 blockchains, the account that you own has a unique identifier, globally unique identifier, that resides within the chain itself. Everything that you, or it could even be a company, owns, could that be crypto coins, it could be physical assets in the real world that has been represented digitally on the chain, like cars or supply parts for a manufacturing line. They are all represented under your account as objects. So that when you perform a transaction, in your application, and this is where this layer one sort of single layer one piece comes into it, when you're writing your application to perform a transaction, you are literally moving objects from your account to another account. So it's far more simplified in terms of the overall operation. And it does then mean that because these are all objects, all residing under account, I can take those accounts, duplicate them across multiple servers, and I can split the transaction up into lots of small pieces and do everything in parallel. Which, if anybody understands the difference between series and parallel processing basically means I can go far, far faster than I can within series. To give you an idea of the speed difference, we estimate, we've yet to trial this, with any real sort of vigor right now, a typical blockchain block in Bitcoin takes around 10 minutes to process. We're estimating we can perform about 40,000 blocks in that same time.
Wow.
So significantly faster in terms of processing. And obviously for the green discussion in terms of energy consumption, you could therefore look at, well, hang on, if I can do 40,000 times the amount of processing in the same time as it creates a single block in Bitcoin, that's got to be far more power efficient. And of course it is, yes.
And for any techies listening, I'm not sure how deep you're going to be able to go on here because you might not be able to reveal too much, but is there anything else you can expand on how you've designed this next evolution of blockchain architecture?
It was really looking at so our focus as a chain is more around the industrial use cases. So supply chains, manufacturing, pharmaceutical trials, those sorts of things, highly regulated industries. And what we wanted to do was to make this as simplified as possible from an adoption perspective. And so one of the big things that we did is to ensure that the language that we're using from a user perspective, the people who are building the apps on top of our chain, isn't Solidity and it isn't Rust. In fact, we're using Python. So it's got one of the largest developer communities on the planet. We've tweaked it a little bit to allow us to have our own customized base software classes to interact with the chain. And net effect is what we have is effectively an operating system for a blockchain. So when people create their apps, they're writing in a language they already know. It's far more simplified in terms of the thought processes from a translation from a real world process that you have in front of you, and how you would reflect that in the software that you're designing, because it is just object oriented. I can create all of the things that are on my manufacturing line, and I can call them classes in my application that are reflected on the chain. And all of the parts and everything else can just be objects within the chain that we just pass back and forth. That was really important to us to ensure that user adoption was as simple as possible. And when you look at the industrial space, the likes of the big manufacturing companies, they have fairly significant IT departments and are doing a lot of data analysis and software engineering already. The language of choice at a lot of these locations is Python, frankly. So if we can make that simpler for them to adhere to, then they no longer have to retrain their developers into a new language, nor do they have to go find effectively a hen's tooth, if you will, on the market for these type of developers, because they're quite a rare breed. There's not many of them out there trained in these languages. So we've kind of broken down some of these adoption problems. The architecture itself is really trying to get away from this notion of having too many layers. We literally just wanted it to just look and feel just like an operating system, in that you are just talking to the operating system and asking it to create things, to move things between accounts, create accounts, and that's roughly about as complicated as it gets. So yeah, simplification has been really as big a sort of technology challenge as much as anything else.
And before you came on the podcast today, I was doing a little bit of research on you guys, and one of the things that I quickly learned was that you recently announced SagaPython at Consensus 2022. Yep. Can you tell me more about that and what particularly excites you about that announcement too?
Yeah, and this reflects back to kind of this notion that Python is the world's most established software language. SagaPython is our tweaked version of it, which basically adds a few additional classes that look and feel and operate just like any other Python class. The training associated with coming on board and starting to learn how to create apps on PraSaga or SagaChain is much reduced, because it is a familiar construct that the people are already using. So it was a huge thing. And the announcement of Consensus was specifically to say that we're open. We're open for business now. You can start creating your apps based on the content that we have put out there, which describes how you would leverage the SagaPython base classes to create the apps that will yield value within the industry. In fact, we've taken it a step further. and we are just going through the processes now to make all of the source code for our software open source. So in the coming weeks, we'll have that available to anyone who wants to develop on our chain. They'll have all of the source code that we're using for the classes available to them.
And I'm conscious we're talking a lot here about bringing simplicity into the blockchain. So do you have any use cases that you could share that would just, I don't know, bring that subject to life and how you're bringing simplicity into the blockchain and also the benefits that's resulting of that?
Absolutely. One of the sort of primary use cases that we actually tested in some of our early stages of this project was looking at an automotive supply chain. And one of the specific challenges in the automotive space is around vehicle recalls. So if you think today, if a vehicle recall is necessary, the first thing that needs to happen is the manufacturer of those cars needs to figure out which vehicles they need to recall. Anybody who's been in any manufacturing discipline knows that getting access to all of the paperwork, all of the audit trail, all of the QA sign-off associated with these things is a bit of a rat's nest. It's often spread out over multiple different systems. Sometimes the paperwork isn't complete. Sometimes it's just not even there. All of those sorts of problems frankly disappear by having your supply chain and manufacturing operations connected to a blockchain. Because then every step along the path of building the vehicle, from creating the raw materials, making the sheet metal, for example, or the nuts and bolts, or whatever it may be, and having those listed in the blockchain as parts that get consumed and sold and moved between enterprises. That entire history from effectively the earth to the finished vehicle is all available on the chain, so that your final vehicle that you have literally knows everything about every part that's involved, all of the QA test results that have happened to all of the components along the way, such that at the point of it's been sold, and if there's a vehicle recall that needs to happen, instead of pulling paperwork together to identify which vehicles and which parts are affected, you now just need to perform essentially a big data search across the blockchain. So what we've done is we've taken something which today takes anywhere from 6 to 12 months to pull the paperwork together, including all the regulatory needs with the automotive bodies and the governments who obviously track these things, to something that could become a handful of minutes searching data through the chain, pulling together the data report. And if the governments and the regulatory bodies were connected to the same public chain, they would have access to all of the same data at the same time. So we've squashed that timeline right down to, let's be generous, a week or two. Okay? Something that today costs manufacturers, frankly, hundreds of thousands of dollars, pounds, whatever you wish, to pull together before you even start having to do any repair work or replacement on the vehicles, becomes almost an automated task.
And I also wanted to highlight that PraSaga is a Swiss foundation. I've spoke to quite a few different blockchain crypto companies based in Switzerland. So can you tell me more about blockchain and the crypto scene in Switzerland? Because it seems like there's a real community and vibrant tech community there.
There is, and there's a couple of different reasons for that to be the case. Switzerland is wonderfully open about the use of crypto assets in their country and managing a company that is either a blockchain or a crypto coin or something of that nature. Other countries around the world are still trying to figure out how they regulate these kind of industries. The US is going to become far more complicated on that space. So, the SEC is really not a body that anybody wishes to mess with in terms of kind of how you regulate a cryptocurrency, not least in terms of taxes and capital gains and all of those sorts of things. Switzerland has got it pretty well figured out. they're very open, and they want to encourage the use of crypto assets within their country. So that's one of the reasons why many people have chosen that to be their sort of a headquarters. We are based in Zug at a company called CV Labs. They host many different crypto organizations under the same roof. So there's a huge community that's sort of driving through this area for sure. So if nothing else, it helps us all understand and discuss and talk to each other. And there are events and sort of communities that we can get involved in to, frankly, help the projects progress, get noticed, bring funding through, which is also important, and so on and so forth.
Fantastic. And I'm also conscious that we will have many loyal members of your community who have been patiently listening to this somewhat of an overview of what you're doing today, and in the slight hope that there might be an update or teaser or something like that. So is there anything you can leave us with about what we can expect from PraSaga over the next 12 months?
So over the next 12 months, we have publicly posted our roadmap to our various communities. So if you're on Discord or if you're into Telegram, we have our public channels, announcement channels there. Our general plan, high-level plan, is that we will be doing the public testnet around Q4, so about October, November time this year. We are on track for achieving that goal. And then we would migrate into the mainnet, which is when we can start looking at listing on exchanges around about February, March next year. Again, we're still looking like we're on track for that. The twist to where we were originally thinking is we're now going open source within the next week or so. So if you've ever wanted to start looking at what it is that we're doing and how the classes are coming together, then we will have all of that on our GitLab server, I'll say within the next week or so. So keep an eye on that. Our xbomb.io website will have all of the relevant announcements and links and content that you need to get started.
Before I let you go, though, I always like to have a bit of fun with my guests and ask them to leave everyone listening with a personal note of inspiration. So is there a song that you'd like to share with us and a story behind that song of how it's inspired you, how it helps you get your head in the zone that we can add to our Spotify playlist? Or do you have a book that you'd like to recommend that we can add to our Amazon wish list?
Wow, blimey. Okay. I am a big fan of classical music, okay?
Yeah.
And one of my sort of favorites right now that I listen to a fair amount. Okay, there's two. I'm going to cheat here. One of those is from the Carnival of the Animals. It's a Swan by Camille Saint-Saëns, which is a very sort of nice, reflective piece. And then there's a somewhat more sort of modern piece called Spring One, which is by Max Richter. Either of those two have been kind of like my go-to if I'm really trying to focus my attentions on getting my head down, getting sort of, content created, trying to think through the different use cases and so on and so forth.
Fantastic. Well, I'll get those added to our Spotify playlist. And before I let you go, for anyone just wanting to dig a little bit deeper on PraSaga and everything we talked about today, what's the best starting point for everything?
Two starting points. If you just want to learn a little bit more, then prasaga.com. If you're a developer, then come join our community and get involved at xbomb.io, xbom.io. All of the relevant links to our social media channels and such like are all on both of those two locations.
Well, I'll add both those links to the show notes so people can find you nice and easily. I love chatting with you today, especially about how PraSaga is building this next generation of Layer 1 blockchain and also how that tech is solving many of the limitations that plague first generation Layer 1 blockchains. But more than anything, just thank you for coming on, sharing the story behind that and your personal story too, and leaving us with two great tunes there. So thanks for joining me today, Rich.
No worries. Appreciate the time. Thank you.
I just love learning how they've designed this next evolution of blockchain architecture and talking about how a layer 1 blockchain that achieves the promise that all blockchains have aspired to, one that provides the highest level of resistance against attacks while rewarding its ecosystem of contributors and most importantly, scales in throughput as more resources are added to the network. But you've heard from me today, you've heard from Rich, talking about everything PraSaga. But what are your thoughts? Maybe you want to dig a little bit deeper on some of the tech issues. Maybe you have more questions. Maybe you want to come on the podcast. Whatever it is, please email me now, techblogwriter@outlook.com. We'll keep this conversation going. And I also cordially invite you to join me again tomorrow, where we've got another guest and another topic lined up. But a big thank you for listening as always. And until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.